In this tutorial, we're going to go over how to 3D model the Titan 90L in Fusion 360. Let's first take a look at the Titans of CNC drawing, as this will give us a better understanding of what will be modeling. In our upper left-hand corner here, we have our external thread data sheet, and all this information can be found in a machinist handbook. To the right of it, we have our front view. And if you notice closely, we have a section view dividing this part in half, and we see that down here right below. On our threads here, we have a detailed view, which we can see to the right. Going back to our front view, we have our right view to the right of it, and we have a variety of chamfers and radii stated. To the bottom left-hand corner, we have our isometric view, and it also has a detailed view of the threads, indicating what the major, minor, and pitch diameters are. Now that we've taken a look at our blueprint, let's go jump over to Fusion 360. The very first thing that we're going to do on this part is, because this is a revolved part that you would make on a lathe, we're going to draw in a center axis, the length of the part. So we're going to go L on the keyboard for line, and we see our triad appear with the three various planes that we can create our sketch onto. We're going to start our sketch on our top plane, and then we're going to anchor our sketch to our origin here and draw a nice horizontal line across our part. And this line needs to be dimensioned at 1 inch 605 thousandths. Now that we have our line in place, we're going to start adding in some other line geometry. So back to L on the keyboard. And we're going to start at the front of our part here. And we're going to add in this flange feature, like so. And then we're going to take a look at the back of our part. We're going to draw in the boss of our threads, the thread relief, the back side of our part, and then this line that intersects everything. Be mindful right now, we're just sketching in some geometry, and we're going to add in some constraints and then also some dimensions that will fully constrain this part. While we're here, we're going to add in a constraint. We're going to use the horizontal and vertical constraint. And we're going to indicate that this endpoint here and this endpoint here are perfectly horizontal to each other. Once we've added those in, we're ready to start adding in our dimensions. D on the keyboard for dimension. And we're going to take a look at our horizontal dimensions first. And we're going to be referencing off our origin location. So from our origin to this first point, we're going to land this measurement, and this needs to be 200 thousandths. From our origin to the back side of our flange, this needs to be 1 inch 240 thousandths. From our origin to the back side of our thread relief, this needs to be 1 inch 305 thousandths. Now that we have our horizontal measurements in place, we're going to start adding in some vertical measurements the same exact way. The outside radius of our part is 475 thousandths. Notice how when I did this point kind of jumped out off our part. That's okay, we can always drag it back onto our part. Back to dimensions. Our next dimension here is to this point. And this point needs to be 367 thousandths. Next dimension is one of these points that makes up the bottom of our thread relief. For this measurement, we're going to look at our detailed view. This needs to be 240 thousandths. And that's a diameter measurement, so we're going to divide it by 2. And then lastly, the diameter of the boss for our major diameter of our threads. Again, you can see this in the detailed view, 367 thousandths, and divide that by 2. Notice once we get all those dimensions in place, our sketch has turned black in color. This means that it is fully constrained, meaning that we cannot add any more dimensions to it. Now that I have those dimensions in place, I'm going to add these kind of radius circles here that kind of intersect our part. There are 5 circles in total, so all I'm going to do is sketch 5 circles. They can be of various sizes because we're going to add in a constraint to these. We're going to go up to our constraints after you draw your 5 circles and go to equal. The circumference of this circle and this circle are equal to each other. And we're just going to repeat that process all the way down these circles. Afterwards, we're going to dimension one of those circles. Doesn't matter which one. And the circle diameter needs to be 100 thousandths. Now that we have the diameters of our circles stated, we need to give each one of these circles a location. Again, we're going to reference off of our origin here, and we're going to drag up, giving us a horizontal measurement of 544 thousandths for the first one. From the origin to the second one, 683. From the origin to the third one, 822. Origin to the fourth, 961. And our last one, origin, 1 inch, 100 thousandths. Notice when you start adding in those dimensions, your sketch object will kind of move around on your modeling workspace. Before we move on, I'm going to kind of clean up some of my dimensions here so I can better read them. All you have to do is click on the extension line or the dimension line and kind of drag it up into place. And what I like to do is have my dimensions really well organized here so you can read them at a glance, like so. Now that we have our horizontal measurements in place, we're going to add in the remaining balance of our vertical measurements. D on the keyboard, from our origin to this first circle. This needs to be 425 thousandths. Origin to the second circle, 440. The third circle, 456. The fourth circle, 471, and our last circle, 486. Again, notice that once we have those dimensions in place, the sketch objects have turned from blue to black. And we're going to come over here and reorganize our dimensions like we did before. And it just takes a few seconds to kind of reorganize these that we can easily read them. Like so. We're going to finish our sketch. And now we see the profile that we're going to revolve. We're going to go to Create and down to Revolve. We're going to click on this profile here. And we are not going to click on the circles. In our pop-up window here, we're going to select our axis. And the axis is going to be the center line of our part. And then press OK. We're going to add in a couple missing features on here. Modify down to chamfer. The first chamfer that we're going to add in is this big chamfer here, and we can see this in our right view. This has a dimension of 60 thousandths at 45 degrees, and then press OK. While we're here, we're going to add in our chamfers for our threads. Right-click Repeat Chamfer. We're going to click on the two lines that make up the edges of this boss. And these need to be dimensioned at 35 thousandths at 45 degrees. We're going to start adding in some of the fillets here that kind of blend our part together so we don't have any sharp edges. Modify down to fillet. The very first fillet we're going to add in is over here. This particular fillet's got a radius of 100 thousandths. Afterwards, right-click Repeat. We're going to choose these 10 thousandths radiuses, or radii, that can be seen in our right-hand view. We have one here, and then we have one on each one of these little webs here that kind of blends that web into the radius underneath it. And then make sure you're choosing the outside line that kind of blends into that chamfer that we just added in. Notice we have 12 edges, which directly coincides to our print. And this needs to have a dimension of 10 thousandths. Once I have that, we're going to add in the fillets at the bottom of our thread relief. Right-click Repeat. We have two lines that make up the edges of our thread relief here. We're going to type in 20 thousandths here. And we see that kind of transition there. Almost done with our other features here. We're going to add in the remaining balance of chamfers, modify down to chamfer. We're going to click on the face here where it kind of transitions from this 60 thousandths chamfer into this face. And then we're going to click on the outside portion of our flange. And these need to be chamfered at 10 thousandths at 45 degrees. We're going to apply our threads to our boss here. So create down to thread. We're going to click on the face that makes up the boss. In our pop-up window here, we are going to choose modeled threads. We are going to be using the decimal equivalent of 3/8 16 threads, so 375 thousandths. Our designation is 3/8 16 unified course, and we are using class 2A, which is a mid-fit. And then press OK. The last thing that we're going to add on our part here is our tapped hole on the bottom. We're going to create a new sketch. So create new sketch. We're going to click on this face here. And what we're going to do is we're going to snap a point. So what I like to do is I click my point kind of away from my origin. And then I'm going to add a coincident constraint between that point and the origin there. That way I'm ensuring that that point resides right on the origin. Afterwards, I'm going to finish my sketch. And then we're going to go to create down to hole. What I like to do is I click on anywhere in the space here, setting my hole, and then I'm going to click in the reference here, and I'm going to turn off the visibility of my origin in my browser tab here. And I'm going to click on that point that I just landed. This way we're ensuring that our hole is going to be concentric to the outside of our part. Now that we have the hole location chosen, we're going to start filling out our pop-up window. Our hole type is simple. This is going to be tapped for threads. It does have an offset on it, and you can see that in the bottom view where the hole goes a little bit deeper than the threads. Underneath, we're going to start filling out these edit windows here. The entire depth of the hole is 700 thousandths. We're going to skip this next edit window because that's indicating if where the threads actually start in the hole. We want the thread depth to go down 400 thousandths minimum. We are using a 140 degree included drill point angle. And then underneath, we're going to choose the decimal equivalent of half, which is 500 thousandths. The designation on these threads is half 13 unified course. And these are class 2B threads, which is a mid-fit. You can have modeled or unmodeled threads chosen here, as this does not matter. Afterwards, we're going to press enter on the keyboard. And we can turn off the visibility of our primary sketches. And notice we have our threads tapped into our hole. It's a good opportunity. Double check your part. Make sure you've got all your features in place. And this concludes the tutorial on how to 3D model the Titan 90L in Fusion 360.